Copilot is everywhere, but nobody wants it. The slogan was, "A PC you can talk to," but users are furious, and now no one is paying for it. Out of 450 million commercial 365 seats, those using paid Copilot seats is just 3.3%. And it's not just users annoyed at Microsoft. Microsoft's market cap dropped $500 billion in a single week after they announced more AI spend. Yet, there's something even worse about Copilot. This might be Microsoft's biggest disaster in history. Over 96% of its own Microsoft 365 customer base still isn't paying for Copilot. And what makes this even stranger is Microsoft's wild expectations for Copilot. This thing is everywhere. If you're on Windows 11, click the taskbar search button and you'll see it in the top right. So, what is Copilot actually for?
Hey Copilot.
Hey Copilot.
Hey Copilot.
Show me how to sync my holiday lights to my music.
Let's walk through it together.
Hey Copilot, why are we so far behind?
Toy assembly has declined due to hot cocoa consumption.
You talking to your computer?
That was the pitch. PC you can talk to. Basically, Microsoft's Do Stuff For Me assistant. It would find a window setting for you instead of digging through menus. Menus which Microsoft had made notoriously annoying, but I digress. It could analyze data in Excel, or create charts and formulas, create a presentation deck in PowerPoint based on a Word doc, summarize and reply in Outlook based on info in your 365 apps. But it wasn't just for 365 apps either. It was integrated into Windows itself. You could ask it to find your local files, summarize and compare them, even the ones in OneDrive. It wasn't just your day-to-day tasks either. A huge part of AI use is programming. You could argue that building code is the biggest market for AI products, and Microsoft wanted in. They already own GitHub, which they bought in 2018, the largest code hosting and collaborating platform on Earth. So combine that with Copilot too. Microsoft rolled out GitHub Copilot. It's pretty much like other AI agents that work in your editor, except instead of GPT or Claude, it was Copilot. Overall, some of the things Microsoft said about Copilot sounded pretty great. Asking an agent to pull up files, like a robust search function, or being able to cross between all kinds of files and Windows apps at once. Sounds pretty convenient, if it actually works. Though Satya Nadella, Microsoft CEO, believed it would be much bigger. He said it would be essentially a new category of computing.
It's almost as though every new version of DLSS rewrites the rules about how much extra we can hope to extract from a game's base image. And DLSS 5 is, in my opinion, potentially the biggest leap yet. Because this is where it finally stops just improving the upscaling and denoising of the existing image, and actually just starts re-envisioning how it should have looked in the first place. This is extremely powerful, quite scary, and very, very controversial. And I think this kind of real-time, high-resolution makeover has implications far beyond the realm of gaming. We saw a small teaser for this technology a while back with the RTX faces, which overlaid an AI-generated face over the top of video game assets, which is kind of weird. So it was very uncanny. But DLSS 5 will maybe do away with some of that uncanniness by applying the effect across the whole image. So yes, it does enhance the faces, but it also overhauls the lighting and detail across the rest of the scene as well, which might help everything to fit in better. Even Nvidia's flagship Unreal 5 based Zora demo sees improvements from using it, and without a face in sight. I'm not quite sure on the specifics of how it works, since at this point it's pretty much magic, but it gets what the game's rendering, path traced or not, and just does more with the information it's been given. So it won't path trace a non-path traced game, but if a game is path traced, then it should be able to get the rays that are bounced about already and to interpret finer details from them, and to produce effects which simply aren't feasible in real time using more conventional methods, like to improve the subsurface scattering and rim lighting and other crudely named effects. You can see it as being kind of like the leap to PBR materials was, only with DLSS 5 it's offloading the interpretation of how materials should look to the neural rendering engine instead. What's impressive about all this is that it's possible in real time, and is flexible enough to work in all manner of games. The downside? they have prioritised getting it working first and foremost, and will now have to spend the rest of this year before release significantly optimising it if they want it to actually be playable on existing hardware. They're using two GeForce 5090s to showcase the technology right now, one to render the game, and another simply focusing on doing DLSS 5, which is a departure from older versions of DLSS, which focused on improving performance. This one, in its current state, looks to be super heavy and demanding on hardware. Of particular concern to me is its VRAM usage. Even now, some current titles like the new Indiana Jones game quickly run into limits on 8GB cards, especially since some DLSS tech like FrameGen already eats into that further already, and I can't imagine that a full-screen neural rendering thingy is going to be light on that stuff either. Now, Nvidia does have some upcoming technologies to help cut VRAM usage, so best case we can hope for is that these two things might cancel each other out. We'll see, but don't dismiss it.
What happens when you ask ChatGPT to reword an email? Your prompt goes to a data center and triggers a wave of computations on hundreds of servers. As those servers get hit with requests from thousands of users at once, they start to heat up. To keep them from overheating, data centers typically cool them with water, fans, and air conditioners. OpenAI doesn't publicly share exactly how much energy or water its models consume, but one researcher we spoke to put together some estimates. For the simplest tasks, like rewording your email, their popular GPT-5 model uses as much electricity as it takes to power a 3-watt LED light bulb for around 20 minutes, and a little less than a teaspoon of water. For one person and one prompt, it may not seem like much. OpenAI says it receives 2.5 billion queries a day. Add those up, and at the very least, you're looking at enough water to meet the daily drinking needs of all the people in Monterrey, Mexico. And enough energy to binge-watch Netflix for more than 3,000 years. The number of AI users is expected to roughly double over the next half-decade. And as AI usage is increasing, so too is the number of data centers needed to support it. That's why researchers are racing to find new and better ways to keep server racks cool, like sinking data centers deep into the ocean and even launching them into space. Cooling has always been a core part of how data centers work. Even one of the first computers in the 1940s had vacuum tubes which were cooled by fans and ventilation. Despite being literally trillions of times more powerful, the data centers of today still look kinda similar. The big difference is they're using a lot more energy. Nearly 50% of their entire energy use can go towards keeping the CPUs that process your prompts, also known as microchips, from overheating. This Google data center in the US state of Oregon is large enough to run computations needed for AI applications. A typical data center covers an area of about 9,000 square meters. This one is 13 times bigger. It's called a hyperscale data center.
The scale of the AI data centers, which we call hyperscalers, is so much larger than the data centers that we have been living with pretty much without even noticing them for the past decade plus.
That's Professor Scanlon from the University of Wisconsin, who wrote this paper about the hidden environmental cost of AI data centers. Packing in more servers means a lot more cooling. Google's hyperscaler in the Dalles, Oregon, used nearly a third of its city's water supply in 2021, according to public records obtained by the state's largest newspaper. Relying on water for cooling is a common approach.